Hi viewer, welcome to EasyElimu channel. I'm Vincent Kanwaya and I'll be taking you through Form 2 Mathematics. And today we are going to learn about reflection and congruence. Let's learn about symmetry, and under symmetry we shall consider a given rectangle. For example, I have here rectangle A, B, C and D. As we can view, this is a rectangle. If we construct a midpoint such that we have a midpoint of AD to be at this point and call that midpoint L, and that of BC to be here, the midpoint of BC, and we call it M. And also we do join the midpoint L and M on the sides of BC and AD respectively through the center of the rectangle. We shall have something of this sort. We are going to have a line running through the center of the rectangle, joining point L and M. On other way, we can also construct a midpoint of AB such that we have it at this point, and also the midpoint of DC to have it at this point. And if we join the midpoints, we shall find, let this of AB be X and this one be Y, and we join the two midpoints, you shall find out that if we do fold this given rectangle, take in mind that maybe it was a folding material such as a paper, and we fold point B to lie to point C here, such that B and C will be in a coincidence. And here also we fold this point here to be on point A to be on D, such that we are folding it along line LM. We shall find that the rectangle there fits, geometrical fit into DC, giving equal parts. For example, we shall see using our example here. I constructed one here. I have a piece of paper resembling a rectangle, as you can see. In case if it's on a board, you will find out that this is a rectangle having point A, B, C and D, just as it has been drawn on the board. And you will find out that the lines which I'm talking about, the line LM and the line XM, which are the mediordinates of the respective sides, we can see are there as dotted, so that in case I want to fold this paper along line LM, we shall find out that if I fold along this line LM, this is my L and then M, this is the line, I'll find out that if I fold, I will have one rectangle, as you can see. This is a full one rectangle unfolding along that, so meaning it fits and it has divided the rectangle, as we can see here, into two equal parts. The same if I reopen it and I do the vice versa, whereby I fold along the line XY, whereby X is on my top, the mediordinate of AB, and Y is the mediordinate of line side DC. If I fold that rectangle along that line XY, you will find it still fits and divides the rectangle into two equal parts. And we're having a rectangle of that kind of sort, in that it has been on line XY, that is XY, and now B here as geometrical fit into A. As you can see here, I'm having B here, and that B will fit geometrically into A, as you can see, and giving you two equal parts being brought together to form one rectangle, as we can see here. So meaning that line XY and line LM divides that given rectangle into two equal parts. With that we can say the line of fold, which is X, Y, and also line LM, we refer to them lines of folds. And that line which divide a plane, as we have here, this was our plane, and it was in form of a rectangle. So a line of fall which divides a plane into two equal parts, we do refer to that line as symmetry. I believe you have understood what I mean by symmetry. That a line which is a line of fall in that if you fall a given plane, along that line, it will divide that plane into two equal parts. That is what we refer to as symmetry. As for a rectangle, we can view out, we have two lines of symmetry. One is this along XY and another one is along LM, as we can see. So we can still identify others, like if you have a square which has four sides equal, you will find that a square will give you four lines of symmetry. And if you have a cuboid, will give you three. Cylindrical wood will give you endless, because you will be cutting equally along the line of symmetry will be along, because it has a cylindrical has a circular top and also a circular bottom. In that, if you cut it into two equal parts using one line of symmetry, if at all you are cutting the upper part, that is the side of the circle, and you cut that one in that you cut up to the bottom through the other side, you will find each line you choose as your line of symmetry, you will find it is cutting that cylindrical into two equal parts. So meaning that you will continue cutting it until you find endless number of symmetry. So meaning a cylindrical piece of wood will have endless number of symmetry. The same appears to spherical ball. A spherical ball is, I think you understand it, and if you find the number of symmetries in a spherical ball, you will find they are endless. The same applies to a circle, and so on. So here you can identify how many lines of symmetry does a pentagon have. Or I will give, for a pentagon you will find a pentagon has 5 lines of symmetry, but you will find how many that of hexagon does it have. For example, we are going to consider some of them here, and here I will consider one. Actually, if you cut a sphere such as an orange, let's take an orange to be in the form of a sphere, you will find whatever you will find, if you use a line of symmetry, you will not be using a line of symmetry, because if you cut, you will end up with a plane. You will have one side and another one, that is a plane. The same applies to this cylindrical wood, you will have plane. So that line of symmetry here will refer to as a plane of symmetry. And you will find for an orange you still have endless number of them. I believe with that you can still identify the letters of alphabet which have lines of symmetry. For example, you can find letter A, letter B. For instance, if you have B here, you can cut here, and that is one line of symmetry, and you will find this upper side will fit exactly into the lower side. The same applies to letter C. We have X, Y. We have some like E, H, I, K, M, O, T, U, V, W. Those are some of the letters which have lines of symmetry in alphabet. Now we are going to consider this triangle ABC. As you can see here, is a right angle triangle being reflected under line M, or the mirror M. This will be my mirror with a shining face on top, so that the image will be at the bottom of it. You will find out that if you have an object, whereby my object here will be ABC, that is the triangle, being under reflection M, you will find out that its image will be inverted from what you have on top, but will have the same size. So that at this point, you find this C is just along that, and this is my C prime. B here will be straight down the B, that is B prime, and here I have A prime. What we can find here is that you will find out the image formed has the same size with the object. And the same thing is that the shape does not change. They also have the same shape. And you will find out that those lines which join the points of the object, for example, let's take an instance of B, and the point of the image, corresponding image point, as here is B prime, you will find that the line joining them, as we can see this line here, is perpendicular to the mirror line. This M here is my mirror line, but you will find that the line joining the point of the object and that of the image, actually they are perpendicular to the mirror line. The same applies to the others and even that of C. So, meaning that if you have been given any kind of object and a mirror alongside, you can still find the image by constructing perpendicular or dropping perpendicular to the mirror line. Then you find the corresponding image point with that of the object, taking in mind the distance between the object point and the mirror line. So that is how we can find out. And under reflection, the main rule applies. You will find that under reflection, the image formed will always be inverted to what the object is. So meaning the image is inverted or looks in the other direction. As we can see here, the one on the upper of the mirror is facing down, or the hypotenuse is facing down, but now the image, the hypotenuse is facing the mirror up. So meaning it has been inverted. It's not, yeah, it's virtual. Then the same thing applies, that the shape and the size are the same. So a point on the object and a corresponding point on the image are equidistant from the mirror line, and that we have seen. A line joining a point and its image is perpendicular to the mirror line, as we can see there. And we have already identified that the shape of the image and the shape of that of the object and also the size are the same. So that is how we do say we can find the reflection of a given object in case we have given the mirror where it has been placed. For example, in most of the cases, you will find even this reflection can be double reflection, in that for those who deals with, for example, you may be given some of them on a Cartesian plane, you may be given a reflection which is in a double reflection. For example, you may be given a Cartesian plane that you are reflecting a given object under y-axis. After reflecting it through y-axis, then you are required to reflect it again into y equals to x line. So there, what really matters is you follow the step as it is. If it is through y-axis first, follow that step, and then after doing that, you do the other step. For example, you will find that if you have been given y-axis, if this is my Cartesian plane, and you may be given an image maybe on this side. For example, let's say the image is on this side. If you have been told this image, you should reflect it in y-axis. It means you will be using this the y-axis here as your mirror. So meaning the image will be on this part. So it will be here, but it will be in opposite direction to what this is facing. So it will be resembling this kind. That is what you will find. And remember here, the distance from this point here to the other point which will have formed at this other end will be the same. And also the shape of that image formed and that of the object will be the same. And also the size. So meaning the distance from the points to the other corresponding points are always the same. That is if the reflection is through y-axis. And you may be told maybe it is through y-axis, and then you reflect it again after finding the image. If this is A, point A, this will be A prime. under first reflection, and then you are being asked to find the reflection again of that image formed through y equals to x. What do? You construct a line of y equals to x, and you understand that one will have positive gradient and will pass through the origin of that Cartesian plane. So we'll pass through the origin, like for example this K. And after drawing that, you are going to reflect your image, that is the first image, through y equals to x through this line. So you will find this point here will be reflected to other side. So it will be following this. You remember this line we said is perpendicular. The line joining the point and the image formed will be perpendicular to the mirror line. And remember here, now our first image here will be now the object which we shall be reflecting under this reflection line of y equals to x. And you will find the image formed will be at this point, and that will be now, if this one was C prime, this was B prime, then this point here will be C double prime, because it has undergone two successive reflection from the initial one here. So that is how it will be. And then this B here, you also draw a perpendicular line joining the points of this B prime to the other point of B double prime, and you will find there will be like that resemblance, and this A will be on this side because the mirror line has cut the triangle at that point, and you will find this one will be at a point like here. So that is A double prime, and you join your triangle, you will find you are going to have a kind of a sort like that. So you will find that the image formed has been inverted in that kind, and it is already of the same size with the initial, but the only difference is that now this one is like it has been tilted if you consider with the first object. So that is how we do successive reflection. So meaning that sometimes you may be required to reflect a given object under different conditions. For example, it may be y-axis, sometimes it's x-axis, and sometimes you may be given y equals to c, for example, y equals to 2, or even you may be given a linear equation. You are reflecting through a linear equation, for example, y equals to 3x plus 4. You use that one as your mirror line. It doesn't matter. It may be even y equals to x, x equals to 2, in that you will find is a line parallel to y-axis. For example, if it is that the line, so this is x equals to 2, you will be reflecting your image under that. The same apply if it is the x-axis. For example, this one will be down here, and take into consideration the equidistance from the point of reflection, actually the point of the object to the mirror line, and to that of the object. That is what we do consider most in reflection. We are going to learn about some geometrical deduction using reflection, and the first area we are going to consider is vertically opposite angles are equal. We need to use reflection to show that vertically opposite angles are always equal in geometrical construction. For example, I have here two lines intersecting each other. This is line L1 and this one is L2. And there we can witness that we have some angles there which will form if the lines intersect each other. And for this case, I have an angle which forms, for example, line L1 and L2 are intersecting at this point. So meaning at this point we shall have angle here, another one is here, another one is here, as you can see. Let's give the angles such letters like this one to be A, this one be B, which is vertically opposite to that angle, this one C, and this one D. You will find out that angle A, the one which is on top, which is vertically opposite to it, you will find is angle B. The same apply to C, you will find is D. Then I draw a mirror line. such that it cuts at angle C and D, as we can see here. It cuts it in that case. Let's call that mirror line as M. You will find that it cuts that angle into two equal parts, each of the angle, that is C and D. Let's call this angle which is cut, that of angle C here, the first one here BC1, and this angle here BC2. But remember, this all is just angle C. The same apply to this of D. Let's give a name that this one is D1 and this one is D2. But the whole of it will give you angle D, as we can see. From there we know one thing, that if we take angles on a straight line, you will find that they add up to 180 degrees. For instance, let's take the angles which are on top of the mirror line. That is angle D1, B, and C1. You will find that if you take D1 plus B plus C1, you are going to get 180 degrees. Reason being, these are angles on a straight line, and they usually add up to 180 degrees, as we can see there. The same applies to the angle D2A, D2 plus A plus C2. They are also 180 degrees, and the same deduction is still the same. Angles on a straight line add up to 180 degrees, as we can see. But remember one thing, since we said here in that if you take this D1 and D2, they are equal because the mirror line is cutting angle D into two equal parts. Therefore, we can say D1 plus D2 will be equal to D, implying that D1 is equal to D2, and that we shall see it by that mirror line, so that is by reflection. By reflection, we can see that one actually line of the mirror or mirror line there bisect that angle D into two equal parts. So angle D is being bisected to D1 and D2, and the same applies to angle C. So we are going to find that angle C1 plus C2 is equal to C, but this implies that C1 is equal to C2, as we can see from the deduction the mirror line has done to that angle. So that is what we shall have. So that means that if we take D1 plus D1 plus D2, we shall get D. But remember one thing, we said D1 plus B plus C1 is equal to 180 degrees. And here we are deducting that C1 plus C2 is equal to C. But remember, C1 and C2 are equal. The same applies to D1 and D2 are equal. If D1 and D2 are equal and C1 and C2 are equal, then that implies that if all of them are adding up to 180 degrees and this one is up to 180 degrees, then B and A must be equal. So we shall find that angles B is equal to angle A, and that is by that deduction we have seen there. And these two angles, as you can see, they are vertically opposite. They are vertically opposite angles, as we can see from the diagram there. So that is the deduction we do take from there. But at the same time, we can consider along line L2 and L1, in that we can consider along L1, line L1, such that we have B plus C1 plus C2 equals to 180 degrees. And still the same reason applies, that is angles on a straight line. add up to 180 degrees. And we can see also, if you do the other way, if we take on line L2, this was on line L1, but on line L2, you will find out that if you take D2 plus D1 plus B, you are going to get this one here is going to give you also 180 degrees. And these are angles on a straight line. And we know angles on a straight line add up to 180 degrees. So, as we can view there, we can deduct that since B here is common, so we can find out that we are going to have this angle D1, D2 plus B, we are getting 180, and the same applies there, so B is common through them. And that deduction means that if you take C1 plus C2, you are going to get that that one will give you angle C. And the same applies that D1 plus D2 is equal to angle D. So if that is the case, then it implies that if B was common through them, then if you take the whole, for example, on line L2, the angles you will get 180, and B is common if you take even that of L1. Then it deduces that if you take C1 plus C2 will be equal to D1 plus D2. That is C1 plus C2 you will get is equal to D1 plus D2. But remember one thing, we have said that C1 plus C2, from what we had earlier from the mirror line, the work of mirror line to that angle, we found it bisects line D into two equal parts, into two equal angles, that's D1 and D2. And we have seen that if you take D1 plus D2, you're going to get angle D. So meaning that here we can replace this with angle D, and the same with this is angle C. So therefore, angle C is equal to angle D, and that one we have seen through reflection, which has been done by that of angle line. And this one there, they are vertically opposite angles. So we can just say these are vertically opposite angles. And I think you understand how I deduced that information there. So next we are going to consider another one. The base angles of isosceles triangle are the same. But remember one thing, as we can see here, it means that if two straight lines intersect, then the vertically opposite angles lying on that intersection of those two straight lines, they are equal or the same. Let's now consider base angles of isosceles triangle are equal. Let's prove that theorem if it is true. We shall construct one of the isosceles triangle here and find out if the base angles are equal. Let's consider that kind of a triangle ABC, in that it is a right angle triangle with one of the angle being labeled as X. And as we can see here, we can make a mirror line along line AC. Let's make a mirror line along this line here, such that line AC becomes our mirror line. You will find out that the reflection will occur, and this triangle here will be reflected into the other side. That's what you find. And this angle becomes our angle X prime because it has been reflected to that side. And also the side here, which was this side here, will be reflected to the other side, and this one becomes B prime. As you can see here, we have formed a triangle from a reflection and its image, whereby ACB or ABC is the real object and AB prime C is the reflection, whereby A prime intersects or coincides with the A. So just that is the mirror line, and that's the point where our image also forms for A and C. So from there we can deduce that line AB is equal to line AB prime. And you can see that if you reflect this line through this mirror line, you will find out that it will move to this side here, and meaning that this line AB will be extended to other side, and that is will be reflected to become line AB prime, and that is what we shall have there. And as you can see here, line AC is common, and that is what we are using as our mirror line, is common between them. And there, as we can also see, since we say that the object formed under reflection is the same as the image, then it really means that triangle ABC is, this triangle ABC is equal to triangle AB prime C. As we can see, that is by reflection. And as you can see, if that is the case, if we reflect line CB under the mirror line AC, you will find like that CB will be equal to CB prime, and that is still by reflection. If you do that by reflection, you will find it's still the same. And since this angle is also 90 degrees, then that means that angle AB prime C is equal to this angle ABC. That is, angle X is equal to angle X prime, as you can see. And since this angle here is the base angles, they are the base angles to our triangle ABB prime. That is triangle ABB prime will be isosceles. The reason being the base angles here are the same. We have found the base angles are the same since we have deduced out and find out what we can say there. So meaning that the base angles will be the same, and if the base angles are the same and line AB prime and AB are the same, then means that is an isosceles triangle. Let's now find out if the angle sum, if you sum all the angles in a triangle, does it add up to 180 degrees? Here I have constructed two triangles, in that my first triangle is AB with the angle A, B, and C. I constructed that triangle and reflected it, and we reflect it under line, our mirror line M, such that that is my mirror line. And if you reflect that triangle, you will find that the angles of the triangle which I have there will be vertically inverted downwards, so that you will have A prime here. Here is angle B prime, angle C prime, and here will be angle B prime. Since we said in reflection the image formed is the same size and shape with the object, then it means the angles which have been reflected are the same to that of the object. That of the image are the same with that of the object. And we know one thing, as you can see from this figure, we are finding that it is forming a quadrilateral figure. And all quadrilateral figure, if you add the angles in a quadrilateral figure, you will find that they will all sum up to 360 degrees. So that implies that if we take A plus B plus C, we add to that angle A prime plus B prime plus C prime, we are required to find 360 degrees. We should get 360 degrees. So if that is the case, and we have really said that indeed A, B, C of the object triangle are the same angles with the image triangle, that is A prime, C prime, B prime. So meaning that the prime will not interfere. So if we add, we are going to get 2a plus 2b plus 2c is equal to 360 degrees. Reason being that angle A and A prime are equal, B and B prime are equal, C and C prime are equal. This is what I'm trying to say. That's what I'm trying to say. If that is the case, then this one applies. So that we are going to have 2a plus 2b plus 2c, and if we factor out, we are going to have 2 into a plus b plus c, and we shall find that that one will give us 360 degrees. If we do divide both sides by 2 in order to find what does the internal bracket only add up to, we shall find that if you divide this side by 2, the other side by 2, you will find out that you are going to have a plus b plus c, and this one will give you 2 here 1, 2 here into 360, you will get is 180 degrees. So we are going to find this one is 180 degrees, and that is by calculation as we can see there. So meaning that if you sum up a plus b plus c, you will get 180 degrees. And these are the corresponding angles of the given sides or the given angles of that triangle or object triangle. So meaning that if you take this triangle in this triangle, you add it to this, you add it to this, you are going to get this triangle will add up to 180 degrees. And that means since A and A prime or the corresponding angles with the image and object are the same, then if you add them, you will also find the image angles also add up to 180 degrees. And that's what we have found. So we have concluded and also seen that angles in a triangle add up to 180 degrees with a help of reflection, as we can see there. Next we are going to consider a kite and a rhombus. Let's now consider a kite and a rhombus, and under this I'm going to consider a kite, and we need to show that angles in a kite add up to 360 degrees. So here I will decide one thing. We may decide this is my kite here. I have kite A, B, C, D. We decide AB equal to AD and BC equals to BC. So here I may use this part here. Actually the sides are equal. Let me take that of the sides equal. I'm going to use AC as my mirror line. And if that is the mirror line, then it means I have now constructed a triangle here, which is ADC. Let me name this angle as A, this one as D, and this one as C. I will find out that if that is the case, under this mirror line, you will find that this triangle will be reflected to the other side in the position in which it is lying. And that means that this angle here will be angle A prime, this one will become D prime, and this one will be C prime. And thereby, in our previous session, we did say that angles in a triangle add up to 180 degrees. So, implying that if I take A plus B plus C, I will get 180 degrees. But remember here now, after reflection, A will be equal to A prime, D will be equal to D prime, and C will be equal to C prime. Implying that if I take A plus D plus C prime plus D prime plus A prime, I will get a total of 360 degrees. If I choose to do the other way round, in that I use now BD as my mirror line, I'll find out that in case I use that, I will find this angle, if I name this angle as, let's just say this angle here as A, this one I give it now B, and this one will be B prime on reflection, or B, let it be D. On reflection, this one is going to be D prime, this one is B prime, and this one here will be my A prime, all of it. So I will find the same deduction will apply, since if I take A plus B plus D, I will get it's 180 degrees. And since the two triangles are the same after reflection, that of the image and the object, then it implies that if you add all the angles in the two triangles, you will find it's 360 degrees. That makes up a kite. So as you can view here, you will find out that the diagonals, which is the mirror line, for my case what I was using here, the mirror line AC and the mirror line BD, you will find they will intersect at 90 degrees. So meaning that the diagonals in a kite will intersect at right angles. So that is what we have implied there. So meaning that the angles in a kite add up to 360 degrees. Next, you will consider a special kite, which we refer to a rhombus, and show that the angles, the diagonals of that rhombus intersect at right angle. That is for your assignment or homework. Now let's consider this kind of triangle, in that whereby we are going to consider this straight dotted line here as a mirror line. We need to find out that the mirror line can be used as a perpendicular bisector. And if that is the case, if this is our triangle here, and we have a mirror line like this case, maybe let's give it a P1. We may decide it to be even P2, P3, such that we need to consider that one and find out what shall it do to our given triangle. And we shall find that if it cuts at this point here, you are going to get that on construction from from L to P3 will be equal to the same as moving from P3 to M. That means that line LM has been divided into two equal parts. That is LP3 being equal to P3M. And that one you can see there if you do construct. So if that is the case, then it really implies that if this P1, P2, P3 is present there, then it means it is a perpendicular bisector to line LM. So meaning it bisects line LM into two equal parts, meaning it's a perpendicular bisector. So if that is the case, then it really gives us an information that at this point we shall have a right angle triangle, and this one it will be a 90 degrees angle. Not a right angle triangle, a 90 degrees angle. So if that is the case, we shall view out again that if you move from P1 here at this point to M, and if it is being reflected through this mirror line P1, P2, P3, you will find it the same distance from P1 to L. So meaning that P1M is equal to P1L. And that one is by reflection, and you can see it out if you do construct. So you will find out that's the case. So that implies that this side P1M, we can give it that marks to mean that they're the same. If that is the same, and here is 90 degrees, then it really implies that even this angle here will be the same, since this side is the same as the other side, implying the angle there after reflection will be the same. So we can easily say that angle P1LP3 is equal to angle P1MP3. So that one we can see there, and it really is after construction. So that really implies that triangle P1MP3 is equal to triangle P1LP3, and that is also by construction. So if that is the case and the two are mixed together or joined together to form one triangle, having the same base and join at 90 degrees as we can see here, so that implies that the triangle formed there, that is triangle P1LM3, triangle P1MPL, that's the triangle I'm looking about, that one will be isosceles. Will be isosceles, and that will imply that P1, P2, P3 is a perpendicular bisector to that given triangle. So P1, P2, P3 is a perpendicular bisector which we refer to as mediator, or is a mediator because it is cutting it into two equal parts, so it is in between, so we can refer it to it as a mediator, and it's a perpendicular bisector, and that is what we were using as a mirror line. Next we are going to see how we can find out congruence. We have dealt with reflection, next is congruence. We are going to learn about congruency, and here congruency means that those figures which have the same shape and same size are said to be congruent. So if you find two figures, may it be triangles or any four-sided figure or any solid figure which you may find and they look alike, then you will say they are congruent to each other. So meaning that in case we have a triangle like here, in case we have that kind of triangle or that kind of figures whereby now this one will be acting as my mirror line, then you will find out that this figure will have the same size. Size and shape will be similar to this, or the same size and shape with that of the image. So in that case, we do say that this triangle here, if it is ABC, after reflection gives us A prime, B prime, and C prime, then we say the two are congruent to each other. So if it fits directly into the other, then we shall say that's directly congruent. But for this case first, as we can see, after reflection, this one has directly formed this under first or initial reflection. But in case to fit this one here, we need to rotate this one the other side. We shall rotate it in that we find the same side or the same facing direction as this one, so that it can really fix. So we need to rotate this about B. Actually, it's about B 180 degrees. So we shall be rotating either positive 180 degrees or negative 180 degrees. We shall see it, or you may view it under rotation as we have done. So that is how we can rotate R about B as the origin of or the center of rotation. So you will find the same figure as this. So if you fit it here, it will fit here directly. But as you can see now, it cannot just fit directly, though they have the same shape and size. So in order to fit, we need to rotate it so as to make it fit there. So those figures which are congruent to each other, meaning they have the same size and shape, but cannot fit until you rotate, we say they are in opposite, or they are opposite congruent to each other. Opposite congruent, or we do say they are indirect congruent. We do refer to that kind of congruency as indirect congruent. But sometimes you will find that this shape or this kind of object here, or our triangle here, if you do reflect it successfully under the same kind of reflection, you will find that if I put another reflection or reflecting line here, we shall find a figure. If that is my reflecting line, you will get that you are going to have A double prime, B double prime, and C double prime being the same size and shape as the others, but now this one here is looking alike or is just the same as that of the object, the initial object. So meaning that the image formed after the second mirror, let's call this as mirror line 1 and this one is mirror line 2. So after reflection through mirror line 2, we have an image which looks the same as that of the first one and also the same as this one, but have the same size and shape. But now this one, if we fit it here, it will directly fit without rotation. So such image or such image and object relationship, if we do just take it and fit it directly without rotation, we do say the kind of congruency that has occurred is what we refer to as direct congruency. So that one is direct congruency, but the two have indirect congruency because we need to rotate in order to fit. Learn more about congruent triangles. Triangles are said to be congruent if the letters assigned to the vertices of it are named in such a way that they are given in a corresponding way. For example, if we have two triangles, let's draw it here. If these triangles are congruent to each other, in that if triangle PQR is congruent to triangle ABC, then it really means that side PQ, that is side PQ, corresponds to side AB, and side AC or side PR corresponds to side AC. So PR corresponds to side AC and side QR corresponds to side BC. So this is what it means if triangle PQR is congruent to triangle ABC. Or you can give it in terms of angles such that, let me call this angle P, this is angle Q, this is R, let this one be B, this one A, and this one C. In such a way that you can also give it in terms of angles such that you will have angle P corresponding to angle A, angle Q corresponds to angle B, and angle R corresponds to angle C. Such cases we do say the two triangles are congruent. We have some more cases where you can find out or you may encounter while working out triangles and congruency in triangles, such that you will have two or more triangles satisfying any of the following. Then you will say they are congruent according to the rules and regulations which we shall be looking about. Such that in case you have a triangle having three sides, one of the triangles, three sides, corresponds to each or are the same and similar to each of the other corresponding triangle, such that if this is the first triangle and each side here corresponds, each side of the first triangle corresponds to each side of the other triangle, then we shall say the triangles are congruent to each other by a rule known as side rule, because each side of the first triangle corresponds to the side of the other triangle. If it is PQ, corresponds to AB. If it is PR, corresponds to AC. That's what we do mean by each side of the first triangle or one of the triangle correspond to the other. Then you will find another kind of condition whereby two sides and one of the angle included or an included angle of one of the triangle corresponds with the included angle or two sides of the other triangle and an included angle. Then with that, we can say that they are congruent by side angle side rule, because one of the side and an included angle and also another side of the first triangle is similar and the same with the other triangle. Another condition is that you will have two angles and a side of the first triangle corresponding with the same of that of the other triangle. In that, you will end up with angle, side, side, actually it's angle, angle, side, or it's angle, angle, side rule, or you may find it as, this is where two angles of the first triangle and a side corresponds with the two angles of the other triangle and a side. And sometimes you will find it is an angle, then side, then angle of the first triangle corresponding to the other triangle. So that is the rule which will be used there. Then at a time you will find that it is one angle is a right angle triangle. One angle of the first triangle is a right angle triangle, and then a hypotenuse. Then one side is corresponding to the right angle hypotenuse and one side of the other triangle. Then that one will be guided by a rule known as right angle hypotenuse side rule. That is what we use. In case you find some of the situation like that, then we shall be using there to evaluate out the condition and give out the given condition to each of the situation. So we have one case, and we shall say this is the first, this was the second case, and this was the third case, this is the fourth. We have the fifth case where we have ambiguity. We have ambiguity case, or we may call it ambiguous case. So under ambiguity case, you may find that you have a triangle. The first one may look like this. One of the side and an angle. You have been given one side here, this is two, and then an angle being corresponding to another one. Maybe it may be looking this way, which is almost similar to right angle triangle, but it's not a right angle, whereby this and these two are still the same. You will find still the same. And another one, now an extreme end of it, you find in that case. So if this is x, y, z, and under reflection, you find this one is x prime, or let's take this is y prime, x prime, and then z prime. The same apply to this x double prime, y double prime under this kind of reflection. And then this is z double prime. You will find out that in ambiguity case, this one here will be congruent to the first triangle, since we have one of the side, actually it's angle side rule, or one of the side being congruent to or corresponding to the other case here. So we can see that xy is similar or equal to x prime, y prime. And then here the same applies that yz is similar to y prime, z prime. And angle yxz is equal to angle y prime, x prime, z prime. So there we can reduce that, and that is the only ambiguity case. But here, still the same applies, whereby x prime, y double prime is the same as xy here. Y double prime, z double prime is the same as yz. But now the problem lies with the angle. This angle here, actually in real sense, this angle is not the same as this angle. So meaning, this triangle here and this one will not be congruent to each other. And under congruency, we shall have a symbol which represents the congruency in them. So if we want to say that this triangle is congruent to the other triangle, then we use a symbol which is, some people do call it 3 hyphens, but it is 3 lines. So if you find 3 lines being drawn under something or 2 letters, it means they are congruent to each other. So meaning like this triangle and this one are congruent to each other, and they may lie under this rule too, whereby we have 2 sides and 1 angle being congruent to or corresponding to the other 2 sides and 1 angle of the other triangle. So meaning the 2 triangles are congruent. With that, we have come to the end of our topic today, that is reflection and congruency. I believe the topic has been much more interesting. See you in our next videos.